Hi there, during this session I'm going to be trying to introduce the different types of radioactivity and explaining and identify some of those key characteristics. So first of all, think about what you might already know. Do you know what ionizing radiation is? Do you know what the word ionizing means in particular? Do you already know what types of ionizing radiation exists? So these are the two questions which we're going to consider during this session. So first of all, what is ionizing radiation? So ionizing radiation is radiation composed of particles that individually carry enough energy to liberate an electron from an atom or molecule. So anything which can change an atom or molecule into an ion of some sort. That's where the term ionizing comes from. Now this has a big impact if it is incident upon a living cell, because if you knock off an electron from an atom or molecule in a living cell, there can be a range of different consequences. This could include basic cellular damage, so the cells get damaged. We see that with the likes of radiation burns. If the exposure is high enough, it could kill the cell. Now this is very, very good in some situations. If you see some of the cancer treatment which has been developed today, and that when they will focus ionizing radiation on a certain cell to try and kill off that cell. However, if the exposure is lower and doesn't kill the cell, it can cause the cell to mutate and cause cancer. So we've got something which can actually cure cancer, but also cause cancer in the same time. So that means we have to be very wary about the exposure to ionizing radiation. Now, let's think about the different types of ionizing radiation that you could be exposed to. The first of these is alpha radiation. Now, alpha radiation is made up of 2 neutrons and 2 protons, exactly the same as a helium nuclei. With the 2 neutrons, it has an electric charge of +2, and it has a relative atomic mass of 4. Next we have beta radiation. Beta radiation is a high energy electron. So as it's an electron, it has an electric charge or an equivalent electric charge of -1 and a relative atomic mass of 1,860th of that of a typical nucleon. What's often not mentioned, and it should also be mentioned as well, is that beta radiation comes in a positive form as well. We could also have a high energy positron. A high energy positron is just like an electron, except it is positively charged. So we've got alpha radiation and beta radiation. And finally we have gamma radiation. Now gamma radiation is electromagnetic radiation of a very high energy. So it has no charge, it has no mass, but it has transferring a large amount of energy. Now, those are the basics of what they are, but their characteristics can be looked at in a little more detail. First of all, the penetration power. My little demo here shows how gamma radiation pretty much passes through most things apart from thick lead. Beta radiation can get through some things, but it won't get through thin aluminium. And alpha radiation may not be stopped by a thin level of mica, but it's probably going to be stopped by the skin or paper. So they have different penetrating powers. Not only do they have different penetrating powers, they're also affected by magnetic fields in different ways. Now the effect on a magnetic or electric field of radiation depends on the type of radiation. For instance, gamma radiation has no charge and no mass, so it's not deflected in any way and has no impact. Beta radiation has a charge and also has quite a small mass, so therefore strongly deflected, and the direction of the deflection depends if it's obviously a negative or a positive type of beta radiation. And then alpha radiation, although is more charged, has much, much greater mass than that compared to the beta radiation, so therefore is only deflected weakly. There's only a slight deflection there. So there's some more features of the different types of radiation. If I review this now, so I'm just trying to bring this all together. If I think about alpha radiation, its penetrating power is the least compared to beta and then gamma. Gamma radiation can penetrate through lots of different things. The range of the radiation, due to the penetrating power, these things are related. Alpha radiation gets stopped quickly, beta radiation travels a little bit further, and gamma radiation has a long range of radiation. Now, although alpha has the least penetrating power and the least range of radiation, this means that outside of the body it has the least impact on it. It's not even likely to pass through our skin. Beta radiation would have a medium risk associated with it because it could pass through our skin. And gamma radiation would be the most dangerous because it could pass through pretty much most things to get inside of us. However, it switches around inside the body, because inside the body we're looking at how much likelihood there is of it actually ionizing, so it's the radiation striking something and causing a change of some sort. So suddenly alpha radiation inside the body becomes the most dangerous, beta radiation becomes of medium danger, and gamma radiation becomes the least dangerous because it's likely to just pass straight through us and have no contact whatsoever. Effect by a magnetic field. Alpha radiation, yes, but deflected slightly because of its large mass. Beta radiation, yes, and deflected the greatest amount because it has the smallest mass, but yet similar electric charge. And gamma radiation, there's no impact whatsoever. So having reviewed that, those are the characteristics of the different types of radiation. Some questions for you. Which type of radiation is the most penetrating? Gamma rays. Which type of radiation is the most dangerous inside the body? Alpha rays. Which type of radiation is the most dangerous outside the body? Gamma rays, because they can penetrate inside of you. Which of the following is not a use of radiation? As it happens, prenatal scans, because we wouldn't want any ionizing radiation having an impact on pre-birth babies. So hopefully that's given you some ideas about the different types of radiation and the different characteristics.